So when you hear the term environmental engineer, what comes to mind? Is it someone hugging a tree? Well, the passion is definitely there, but the reality of this job, it's probably not what you think. Let's dig into what it really takes to engineer a cleaner future.
Okay, this quote really hits the nail on the head. Safeguarding our planet's resources. I mean, that's a huge mission, right? It's what draws so many people to this field. But here's the thing. It's not just about having a passion for the environment. It's about rolling up your sleeves and using some serious science and engineering know-how to build actual physical solutions to really tough problems.
Right. So what does this job actually look like on a Tuesday afternoon? Forget the inspirational posters for a second. Are they out in the wilderness every day, or is there a whole other side to it that we never see? Well, we're about to find out. So let's unpack this mission. Being a guardian of the planet sounds awesome, but what does it mean in practice? Turns out, it's way less about capes and more about tackling some seriously complex and often pretty messy problems with some very specialized skills. Think of them as the ultimate scientific detectives and builders, all rolled into one. They take biology, chemistry, and engineering principles, and they mash them all together to create real solutions for our biggest environmental headaches. We're talking everything from cleaning up toxic spills at old factories to designing the massive water treatment plants that keep our cities running.
And, their to-do list is wildly diverse. Seriously, one day they could be head down designing a water reclamation system. The very next, they're putting on a hard hat to inspect a site, making sure every single regulation is being followed to the letter. They're the ones managing hazardous waste, advising the government on new policies. They're basically the translators between a big construction project and a mountain of environmental rules.
Okay, this is probably the biggest surprise for most people. The job is really split between two totally different worlds. You've got the muddy boots, hands-on work out in the field, and then you have the deep thinking, data crunching work that happens in front of a computer screen. Two worlds, one job. So, when they're out in the field, their toolkit is all about staying safe and getting the job done. I'm talking the full getup, hard hat, safety glasses, steel-toe boots, the whole shebang. It's not glamorous. It's often hot or cold or rainy, and you're out there overseeing construction, grabbing soil samples, and making sure everything is running smoothly. And then, bam, they're back in the office, and the toolkit changes completely. Out go the steel-toed boots, in come the high-powered computers. They're using sophisticated software like GIS to map out a problem area, then jumping into AutoCAD to design, piece by piece, the system that's going to fix it. They're even coding in Python to make sense of all the data. This is where the real strategy happens. So you see, these two worlds aren't separate at all. They're constantly feeding each other. The dirt and water samples they collect in the field, that becomes the data they crunch in the office. The complex designs they build in CAD, that's the blueprint for what gets built on site. It's this perfect, continuous loop between hands-on work and brain power. All right, so let's get into the nitty-gritty. How do they actually fix a problem? Picture this. You've got an old, abandoned factory site, and for decades, nasty chemicals have been leaking into the soil. It's a total mess. How do you even begin to fix that? Well, the process has a name: environmental remediation. Remediation is the core of the job for many environmental engineers. It's literally the process of cleaning up messes. We could be talking about a leaky underground fuel tank at a gas station or a huge industrial site that's been polluted for years. The goal is simple: get the bad stuff out of the soil, air, and water. And this whole process follows a pretty logical four-step playbook. First, you got to assess the site, figure out exactly what you're dealing with. Then, you design the fix. This can be some really cool tech, like a system that basically acts as a giant vacuum cleaner for the soil. Step 3 is overseeing construction to make sure that system gets built right. And finally, you monitor everything, collect the data, and report back to prove that your solution is actually working.
So if you look at how their time is spent, it's pretty much an even split between fieldwork and office work, about 40% each. But check this out. The last 20%? That's all communication. And that might be the most important part. We're talking meetings with clients, calls with government regulators, coordinating with different teams. It just goes to show, you can be the smartest engineer in the world, but if you can't explain your ideas, you're not going to get very far. And of course, the job changes over time. What you do as a rookie is way different from what you'll be doing as a seasoned pro. The career path takes you from the field right into the boardroom. So when you first start, yeah, you're going to be in the field, a lot. You'll be getting your hands dirty, overseeing the real work, and learning how everything actually functions on the ground. But as you move up, you'll find yourself in the office more, designing the projects and mentoring the newer engineers. And eventually, at the senior level, it's all about the big picture.
managing huge projects, developing business, and being the go-to person for the clients and regulators. So, after all that, the muddy boots, the spreadsheets, the long meetings, what's the payoff? Why do it? Well, this is the best part. This is where it all comes together. This quote from Carrie Audankep just says it all, doesn't it? That feeling of seeing something go from just an idea on paper to a real three-dimensional thing standing right in front of you doing its job. I mean, getting to be part of the team that makes that happen, that's got to be an amazing feeling.
So just picture it. Here's your before shot, an old, forgotten industrial site. It's contaminated, it's ugly, and it's dangerous. Basically, it's a problem that needs a solution.
And then, here's the after. Because of an engineer's work, that exact same spot can be totally transformed. That wasteland can become a beautiful wetland, a park for the community, a safe place. That is the real world, you can literally touch it, impact of this job. So there you have it. It's one part hardcore science, one part intense project management, and a surprisingly big part communication. It is definitely a tough career, but it's also one of the few jobs where you can actually point to something and say, see that? I helped fix that. The question isn't just what problems we need to solve, but how we're going to engineer the solutions to build a better world.